Hello students and welcome to Mega Course. In this algebra video we are going to study logic part 3. Before we start, please hit the subscribe button for more educational videos from our channel. Let's get started. Starting with conjunctions, let P and Q be two statements. We call conjunction P and Q the following. We use this symbol that is between P and Q to denote it instead of and. Here we say P and Q, or in some universities they say P dot Q or P and Q. The truth value of conjunction, when is conjunction P and Q is true, and when is conjunction P and Q is false. Let T be true and let F be false. Whenever P is false and Q is false, the conjunction P and Q is false. When P is false and Q is true, the conjunction P and Q is false. When P is true and Q is false, the conjunction P and Q is also false. But when both of them are true, P is true and Q is true, then P and Q is true. Let's take an example. I will draw an example on the screen. I will say here, this is a window. This is a window. P here is, the statement P says, this is a chair. I don't know how to write using a cursor or a mouse. Q says this is a gorilla. P is false because this is not a chair, this is a window. And Q is also false because this is not a gorilla, this is a window. So you should say P and Q like this. P and Q is also false. As I explained, they should both be true in order for P and Q to be true. But here in this example, P is false and Q is false, so P and Q is actually false. The next point which is disconjunctions. Let P, as usual, let P be statement and Q be statement. We call the disconjunction between P and Q P or Q. The conjunction was P and Q, but here the disconjunction is P or Q. We denote them in this symbol, P or. This symbol means or, P or Q, or some universities say P plus Q, which means P or Q. The truth table of conjunctions is the following. Let T be true and let F be false. Whenever P is false and Q is false, P or Q, the disconjunction between P and Q, which is P or Q, is false. When P is false and Q is true, the disconjunction P or Q is true. Whenever P is true and Q is false, P or Q is true. Whenever both of them are true, P true and Q true, the disconjunction P or Q is also true. Let's take a conclusion for this. P or Q is true. The disconjunction is between P or Q is true whenever at least one of the two statements is true. If we see here, P or Q is true whenever at least one of them is true. or both of them. And P or Q is false only when P is false and Q is false. Both of them are false, then P or Q is false. Let's take an example here. I will write an example and say the same example. This is a window. This is a window. P here is this is a door, while Q here is this is a window. P here is true. I'm sorry. P here is false because this is a window and P says this is a door. No, P is a window, not a door. But Q is true actually. It says this is a window and it's a window. So the disconjunction P or Q is true. Why? Because at least one of them, which is Q, is true. So this was the example for the disconjunction. But wait a second. Let's take this example for P and Q. P and Q here. P is false. Q is true. P and Q is false. Why is it false? Because at least one of them was false, so the conjunction P and Q is false. Hope you understand it. Now the third point, which is so important, it's very important, is implication. Let, as usual, P a statement, Q a statement, but we call the conditional statement P implies Q, P implies Q, the statement whose truth value is the same truth value of not P, the negation of P, or Q. Let's understand it together. So here we say P implies Q is the same as not P or Q, the negation of P or Q. P implies Q means whenever P is true, we find Q is also true. Let's talk about it. We have a statement P. When P is true, whenever we find a statement P is true, we can find a statement Q which is also true. Hope you understand what I said. In order to understand this more and more, let's talk about it more. In the statement P implies Q. P is the hypothesis and Q is the conclusion. We can call P implies Q in many different ways. P implies Q, the first way, which I already said it. If P, then Q. If P, then Q. And the third one, P is sufficient for Q. Imagine we have a statement P. It is sufficient to say that we have Q. Or P is necessary for Q. We have a statement Q here. In order for Q to happen, P should happen, which means P implies Q also. This is so easy. Hope you understand it. Now the truth table of implication. Whenever P is false and Q is also false, the implication P implies Q is true, or the negation P or Q is true. Let's simplify this more. If we do this column here and name it not P, the negation of P, then this is true because this is false, and this is true because this is false, and this is false because P is true, and this is false. Not P or Q. We said that the or means disconjunction, and both of them should be false. I mean, not P should be false, and Q should be false in order for P implies Q, or not P or Q should be false. Both of the two statements, not P and Q, should be false in order for not P or Q to be false. Here, in the first one, we have not P true and Q is false. Of course, the disconjunction or the implication will be true, since P, at least one of them, which is P, is true. We understood the first one. The second one, we have not P is true and Q is also true. Of course, P implies Q will be true. In the third one, we have not P is false and Q is false, which means P implies Q is of course is false, because both of them are false. Now in the fourth one, not P is false, Q is true, one of them is true, at least one of them is true, which is Q, then P implies Q, or I mean this one, not P. They are both the same. They are both the same. Not P or Q is true. Hope you understand this too. Now, some remarks. Important one. The following. If P is true, then P implies Q is always true. Sorry. If P is false, then P implies Q. The implication P implies Q is always true. Here, if you imagine with me, imagine something false. It can give us something true. We have something false, a false statement. It can give us a true statement. Now, if Q is true, then P implies Q is always true. Imagine a statement P which gives always a true statement, and Q is true. This statement Q is true. So in the previous one we said if P is false, then P implies Q is always true. Imagine if Q is true and P is false. Of course, because of the previous one, we have P implies Q is always true. And if P is true and it gives us a Q statement which is always true, then P implies Q is of course always true. The next one, the converse of P implies Q is Q implies P. The converse of P implies Q is Q implies P. The negation of P implies Q is P and not Q. Let's write this one. We know that P implies Q is the same as not P or Q. The negation of this one, which is the negation of this one, we mean negation P or Q, is negation P, and the negation of or is and. The negation of this conjunction is conjunction, and the negation of conjunction is disconjunction, not negation of Q. negation P is actually P. Imagine you're saying he is on the moon. The negation is he is not on the moon. The negation of the negation is he is on the moon. P and not Q, which is actually here. This stupid mouse here. Now let's erase this one. This. Where is the mouse? Here. Okay. Now the fifth one says the contrapositive of P implies Q, contrapositive of P implies Q is not Q implies not P. Example: if x square does not equals 1, then x does not equals 1. If and then. What do you remember from this? Of course you remember if P then Q. Then we have x square does not equals 1 implies x does not equal 1. Here x square does not equal 1 is P and x does not equal 1 is Q. P implies Q. Not P is the negation of this one, which is x squares equal 1, and the negation of Q here is x equal 1. Okay? In the previous slide I mentioned something which is contrapositive. We will take an exercise to show that contrapositive, which is not Q, implies not P, which is the contrapositive of P implies Q, admits the same truth value. This means that the contrapositive of this conditional statement, which is P implies Q, have the same value as itself, P implies Q. Let's see. It's so big, but it's so easy, I promise. When P is false, not P is true, I will say each statement alone, and then we will say we will see P implies Q and the contrapositive of it. When P is false, not P is true. When P is false, not P is true. When P is true, not P is false. They are the opposite. Same for Q. When Q is false, not Q is true. When Q is true, the negation of Q is false, and so on. Now we have when P is false and Q is false, of course both of them are false, then P implies Q is true. When P is false and Q is true, of course P implies Q is true. When P is true and Q is false, here we have P implies Q is false. When P is true and Q is true, of course both of them are true, then P implies Q is true. Now let's take the negation here. When negation of Q is true and negation of P is true, both of them are true. True implies true, then this statement is true. When not Q, which is negation of Q, is false and not P is true, we have false gives us a true statement, then false implies true is true. But whenever not Q is true, the negation of Q is true, and the negation of P is false, then we have a true statement that gives us a false statement, which gives us a big false implication. Then not Q implies not P is false. Now when not Q is false and not P is false. False gives us false. This is a true statement. A false statement gives us a false statement. Then we have not Q implies not P true. Here we proved it already. We proved the exercise. We showed that P implies Q and not Q implies not P admits the same truth value. Ask me how. How? Here in the same row we have the same values. True, 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 false, false, not true, true. Hope you understood this. This was a very important one. Video we are going to learn equivalences, variables, quantifiers. Stay tuned for the next video. Next time, please subscribe to our channel. Sorry for this video, it was so long, but I hope you understood everything, and goodbye.